Okay, so we're looking at how we can calculate the cost of debt using the internal rate of return. Okay, that is redeemable debt. Okay, debt which has a maturity date. That's how you know the debt is redeemable. They mention a maturity date in the question. Okay, so we're still looking at this question here for TBL PLC. So we're going to focus on the information for the debt. They've told us long-term liabilities, 10% debentures, 7,500, trading for 1 kwacha for ngwe. They've told us in the question here, debentures are redeemable at par in 5 years' time. So since they've told us when the debentures are going to be redeemed, so it's redeemable debt. Okay. If they do not mention that information in the question, then you're dealing with irredeemable debt. So the first thing you need to do is you need to first get your interest payments. Okay? Because this is what you're going to discount or get to get the present values of. All right. So to get your interest payments, it's your interest rate multiplied by the par value, open brackets 1 minus the tax rate. All right, 1 minus the tax rate. So in our question, the interest rate is 10%. The par value is this 1 kwacha here. So when you buy this debt after 5 years, when it matures, you'll be paid this same 1 kwacha. Okay. The tax rate is here 30%. So say 10% of the par value, which is 1 kwacha, open brackets 1 minus 0.3. The 0.3 is the 30% tax rate. So 10% of 1 kwacha is 10 ngwe. 1 minus 0.3, you get 0.7. 0.7 times 0.1, 0.007. So this debt, these debentures, when you purchase one debenture, for 5 years, you'll be receiving interest payments of 7 ngwe. Okay. You purchase this debenture for 1 kwacha for ngwe. This is how much you purchase it at in the securities exchange. 1 kwacha for ngwe. Then for 5 years, you'll be receiving interest payments over 7 ngwe. Then on the final year, the 5th year, apart from receiving your 7 ngwe interest payments, you're also going to be paid this par value, 1 kwacha. You're going to be paid that 1 kwacha. All right. So once you've got the interest payments, the way we calculate the internal rate of return, the same way we're going to do for the cost of our debt. All right. You have your years here. You have your cash flows. Year 0, which is the first day of year 1, you purchase the debt for 1 kwacha for ngwe. For 5 years, you'll be receiving an interest payment of 7 ngwe. On the 5th year, you'll be paid the par value, which is 1 kwacha. So these cash flows, we need to discount them and get the present values. Okay. Just the way we do the internal rate of return. Okay. So for year 0, okay, for your discount factor, you're just going to use 1 plus r to the power negative t. Okay. The discount rate is the interest rate of the debenture. Okay. So that's why here r, that 10% we convert it to 0.1. 0.1 plus 1, that's how we get 1.1. Okay. So for year 0 and year 5, okay, you're going to use this 1 plus r to the power negative t, because these are one-off payments. Okay. But from year 1 to 5, these interest payments represent an annuity. Okay. Equal payments over the same interval of time. Okay, so you use this formula here. Okay, get your discount factor. All right. You can also use the tables. All right. The present value table for the tables, you use the present value table for year 0 and year 5. You use the present value table. Then for here, year 1 to 5, you use the annuity table. Okay. So here now discount factors for year 0, 1.1 to the power negative 0 equals 1. For our interest payments, when we substitute into this formula here, we get 3.791. For year 5, 1.1 to the power negative 5, 0.3855. Okay, these are your discount factors. So to get your present value, it's your cash flow multiplied by discount factor. Okay, so here negative 1.04 times 1, negative 1.04. 0.07 times 3.791 gives 0.265. 1 times 0.3855, have to get 0.3855. And then we add negative 1.04 plus 0.265 with 1.04 plus 0.265 plus 0.3855, we get negative 0.3895. Okay. Then remember, with the internal rate of return technique, you have to have two present values, one positive, one negative. Okay. So if your first present value is negative, remember this: if your first present value is negative, reduce the discount rate. If your first present value is positive, increase the discount rate. So here, since our first present value is negative, so we reduce our discount rate. So I used 1%, okay, to prevent trial and error. So I just was extreme and just say, let me use 1%. So you repeat the same process to get the discount factors, okay? So in this case now, our R is going to be 0.01. Okay, remember this 1 plus R, is 1 plus 0.01. So I've got a 1.01 here. So 1.01 to the power negative 0, that is 1. For our annuity, we plug it into the equation, into the formula, we get 4.853. For the 5th year, you say 1.01 to the power negative 5, 0.951. Then you get the present values again. Negative 1.04 times 1, negative 1.04. 0.07 times 4.853, 0.33971. 1 times 0.951, 0.951. You add your present values, negative 1.04 plus 0.33971 plus 0.951, you get 0.25071. Any questions before I put into the formula now? Okay, so this is the formula for that you need to put. 8% is the lower discount rate. 8% lower discount rate. In this case, it was 1%. B% higher discount rate, which is 10%. NPV 8% net present value with lower discount rate, which is 0.25071. NPV B% net present value with higher discount rate. And it's this one here. When we use 10% as our discount rate, we got this negative 0.385. So it's just 4 things that you need from this table. Okay, colleagues, 4 things. Higher discount rate, lower discount rate. Net present value with the higher discount rate, net present value with the lower discount rate. Okay, just those 4 things. Okay. And then you substitute into your formula. Yeah, just a matter of substitution. And then you solve. Point 25071 plus 0.3895. This negative and negative you make positive, so you're adding. Okay. You start with what's in the brackets here. You subtract these 2, subtract also these 2 here. 10 minus 1, that is 9. 0.25071 minus this number. So negative and negative make positive. So it's like we're adding, and we get 0.64021. Then you divide here 0.2501 by this. Get 0.391. Then this 0.391, you multiply it by 9%. 3.5279. 524. 3.524 plus 1, you get 4.524%. And that is your cost of debt, KD. Okay. The same way we are getting the internal rate of return is the same way